Hello, my name is Alain Stas. I'm product engineer for nonlinear resistors at Vishay. This is the second part of the video dedicated to the electronic simulation with our components, thermistors and RTDs. Like emphasized in part 1, at Vishay Nonlinear Resistors we are keen to provide electronic component models suitable for several EDS software. We are going to focus here on models of PTC elements for current limitation for automotive battery and inverter industries. The models that we provide are intended to be as realistic as possible. They take account of the self-heating and of the VDR effects, of the tolerances, and of the ambient temperature. New LT-SPICE models visualize even the internal PTC temperature, and now we are also able to test the PTC parts in classes for R25. We have a hands-on approach, and later in this video we will show in LT-SPICE 17 how a network of several PTC elements placed in parallel and in series can be arranged in order to optimize the thermal capacity and design safety. Vishay is the first component manufacturer to provide public models of PTC ceramics, in our case PTC-EL, that lead it through all inrush current limiting component range. For PTC, the two principal software that we are dealing with are up to now LT-SPICE 17 from Analog Devices and System Vision Cloud from Siemens EDA. This first simulation example is available on the System Vision Cloud website. The circuit represents a basic switch mode power supply where a PTC-EL network must be able to withstand the initial smooth capacitor charge without switching to high temperature. Every current, every voltage and temperature can be represented. Such simulation can help prepare experimentation and spare hours of tedious trial and error lab work. It's time now for the live simulation of a charge-discharge circuit in LT-SPICE 17. Most of the practical circuits involve a base circuit like this one. A capacitor is charged by a battery and then discharged into the PTC network. The discharge must be completed under a defined level of voltage within a defined time. We can simulate the charge and discharge switches and even simulate cases where the charge and discharge time overlap a bit. The simulation is performed with the very last PTC-EL models selected in classes C1 to C5, where the R25 has a lower tolerance inside the class. The first PTC network that is presented here is balanced because the total resistance on the left part is identical to the one of the right side, and the 6 PTCs are connected with each other through these connections. The simulation can begin now. We have recorded it first in real time, as the computation process goes very fast. In the upper pane, we see that when the charge and discharge switches are open simultaneously during short times, the PTCs heat up already. Thanks to the versatility of LT-SPICE 17, we can represent the temperature in degrees C in the mid pane, while in the simulation the PTC temperature is still a voltage. The capacitor voltage is represented in the lower pane. After a moment, we see that the voltage is becoming lower than the predefined limit here of 60 volt, and this in all the runs which correspond to different Monte Carlo tolerances. The goal is thus reached. What we are going to do now is to remove the connection between the PTC-EL and isolate the different PTC arms from each other. Let's see what happens then. We see that the spread of the reached temperature by the 6 PTC increases a lot. Some parts switch prior to the others, and the capacitor voltage saturates above 60 volts. As a last manipulation, we are going to re-equilibrate the different parallel arms by including in each arm components of the same class. Thus now we have similar components in each arm, and let's see what happens. The spread of the PTC temperature at final stage is back to low, and the capacitor is now discharged within the admitted limits of time and amplitude. Of course, by no means this simulation will never exonerate the engineer of practical work, but at the same time, it is thus obvious that our models can help them prepare their experimentation and to spare a precious time. Well, that's it for the moment. I hope that you enjoyed this video. Thanks for watching.